the normal distribution.
Get a notebook and we need it.
When you know you're dealing with a normal distribution, you know for sure that the graph will be bell-shaped, symmetric, and unimodal. It'll be centered on the mean and spread according to the standard deviation. And we want to be very careful that we do write, the mean will be in the center, so mu will be right here. And then the standard deviation, notice in the curve right where the concavity changes from concave down to concave up, spoon down, spoon up, right at that point, that's going to be one standard deviation above the mean. And then similarly on the other side, where the concavity changes on this side, notice that's exactly where one standard deviation below the mean will be. And I want you to be very careful when you draw these graphs that one standard deviation away is right where that point occurs. And then from there you can get your 2 standard deviations out here, and then 3 standard deviations, and so on. And the spread is always going to be depending on the standard deviation. So immediately when you hear the phrase standard normal distribution, which is also called the Z distribution, you immediately know the mean is 0 and the standard deviation is 1. So again, here's that point where the concavity changes, and you know that that's going to be 1 standard deviation above the mean, and here's 1 standard deviation below. So this would be your Z-scores in the Z distribution. And from here we could find the probabilities that Z is, say, less than negative 1.2. And if we do that, we just locate where negative 1.2 would be. It's going to be between negative 1 and negative 2, closer to negative 1. So if we throw it there, negative 1.2, all the values smaller than that will be to the left, and the probability is going to be the area associated with that range of values. And we get that area on our calculator by using the normal CDF function. Normal CDF. In that area, the low value is negative infinity, and the upper bound is negative 1.2. So we will not move that. We will write negative E99, comma, negative 1.2 is our upper bound, our mean is 0, and our standard deviation is 1. And of course, should have done this beforehand, but I'm giving you a chance to do it on your calculator with me. Negative E99, comma, negative 1.2, comma, 0, comma, 1. And that is a 11.5% chance of happening. I should have asked you that beforehand too. Remember that if you're looking at the area to the right of negative 1, that's about 84. That's about 84%, because half of that curve is 50%. 1 standard deviation below is going to add another 34% from the empirical rule. So I know that this answer, I knew that this answer was going to definitely be less than 16%. So it makes sense. Suppose that the length of workshops at a conference is normally distributed with mean 60 minutes and standard deviation 15 minutes. So our data is the time of a workshop in minutes. And since it's standard normal, I draw the bell-shaped, symmetric, and unimodal curve. And in the middle, I'll have the mean of 60 minutes. And 1 standard deviation away would be right where that 1 standard deviation above would be, again, right where that concavity changes. So there it is, and that would be 60 plus 15, so 75 minutes. And then above that would be 2 standard deviations above, which would be 90. And then on the other side, I'd have 45 minutes and 30 minutes. And that's my distribution of lengths of workshops. So now, given that information, the lengths of workshop, What is the probability that a randomly selected workshop is more than 80 minutes long? So again, the mean was 60, there's 75, and there's 90. And so 80 would be to this side of 75, to the right. And so we want the probability that the length of the workshop is more than 80 minutes long. And more than 80 would be everything to the right. So again, looking for that probability, looking for that area, we would use normal CDF. The left bound of our area, the lower bound is 80, the upper bound is infinity, and my mean is 60, and my standard deviation is 15. And that probability comes out to 0.091. So there's a 9.1% chance that a workshop selected at random will be more than 80 minutes long. So now we'd like to know what the probability that a randomly selected workshop is between 40 and 80 minutes long. So we're looking for the probability that the workshop time is between 40 and 80. And so 40 is going to be just to the left of 45. There's 40. And again, 80 was to the right of 75, so there's 80. So between these two values is going to be all the data value, all the times between those, and the area is going to be that middle area there. Looking at this, I can already see that this this answer is going to be more than 68%, right? Because one standard deviation away would be the middle 68% of the normal curve, and we've gone out a little further than that. So it's always good to approximate your answer before using that calculator. But to get the exact value, we'd use normal CDF, left bound 40, right bound 80, mean is 60, and standard deviation is 15. And there's my result of 0.81875. So 81.8% is my result, which makes sense because it's bigger than the 68% of the one standard deviation away. So for this question, if I tell you that 60% of all workshops are longer than how many minutes, I'm now giving you the percentage rather than giving you the minutes. So this is the problem in reverse. So 60% of all workshops are longer than how many minutes? So I know that 50% of them are longer than 60 minutes, right? Because halfway would be at that mean of 60. So I've got 50% more than that. So if I'm going to need a workshop that's in which 60% is longer, I'm going to have to be to the left of the mean. And I know over here, one standard deviation below the mean, 84% of workshops are longer than that. So 60% of workshops are going to be longer than some value in there. So what I know right now is that this area is 60%. And so I'm going to need to use the inverse norm function on my calculator. But remember, with inverse norm, it doesn't need the area that we've been given here, the 60%. Your calculator always needs the area to the left of your data value. So be aware that you need to use the 40% when using your calculator. So this would be inverse norm, 40%. The mean is 60, the standard deviation is 15, and that workshop comes out to be 56.2 minutes long. Enjoy.